All right, so one of the things I want to review with you, because I know it's important and one of the harder kind, remember how it says between 0 and 360? That's in degrees. So this one you can do in degrees, but it's a hint that there's two answers. Okay, there's two answers for this question. This little thing is giving you a hint. It tells you exactly which quadrant you must be in. Is it A, S, T, or C? All right, so I want you to try to do this one. I'm going to give you a second. God, draw yourself one of those. Always draw yourself one of those in almost every test question. And then figure out what quadrant you're in. Draw yourself a little triangle. Figure out the degrees. Notice I allowed degrees this time because I said between 0 and 360. All right. I'm going to pause while you work on that one. This is how you're supposed to do it. All right. Started it again. You're going to be finding the right quadrant. If cosine's negative, cosine being negative puts me here or here, so I'm going to cross out these. That's where cosine's positive. Okay, so cosine's negative is either in the S or the T area. Where is tangent positive? Of the remaining spots that are possible, it must be in here. Because that's where tangent's positive. It can't be there. All right, now do you know that you have to be down there? Once you know that, then you can start drawing your triangle. And you can say theta. And you can say negative root 3 is cosine's adjacent over hypotenuse. That's A and that's H. Adjacent's negative root 3. And hypotenuse is 2. And then this side right here, can you tell that it's a 1, 2 square root 3 kind? That's a 1, but it's a negative 1 because it's going down. All right. Now, final answer. That's a 30, 60, 90, and that's the 30 part. But if you said 30, you're wrong because the actual answer is it goes all the way around to there, right? So it's 180 plus 30, 210. And if you change it into radians, technically you'd be wrong because in this case, it says it wants degrees. Okay, so I need to know where the sticking point on that was for you. How many of you, the problem was you didn't know to draw the triangle here? Raise your hand if your problem was you didn't know where to draw the triangle. All right, thanks for being honest. Next question. How many of you, when you drew the triangle, had trouble actually knowing where to put the sides on the triangle? All right, so I'm not doing too well asking the questions. How about this? Why don't you tell me where were you stuck? Be honest. It just helps other people and you too. Didn't know how to start. Didn't know that you were supposed to draw a triangle kind of thing? Okay. And as soon as they give you one of these problems, whether it's this or they give you the angle, either way, draw a triangle. You pretty much always draw a triangle. So if you're stuck and you're not sure what to do, draw a triangle. So, like out of 10 questions, no, there's like usually 9 questions, one of which is the R4. I'd say you're seriously going to draw a triangle 6 out of the 8 times, and then the 9th one, you know, probably 6 out of 8 times you're drawing triangles. Yes. Where were you stuck? Okay. When you look at this top thing, it says cosine is, and a lot of people just don't think about it. This is obvious. Tangent is positive. But this, if you just look at cosine, see how it is a negative number? You just look at the sign on it. If there's no negative sign, it must be positive. In this case, cosine is a negative. So that's how I know that I have to rule out these two spots because cosine's positive in these two spots. So you just look at the sign right there. If that's negative, you're saying cosine is negative. Yes, sir. Okay, when you actually draw the triangle, do you get that this is the key, like, place? That's the key place. And so where is that? That's all the way around here. Okay, so when you're done drawing your triangle, the angle that you're talking about, the 30, that's the reference angle. That's not the actual angle. Actual angle is this angle that comes all the way around from the beginning. So let me do a different one like that. So let's say I was like this, and I end up drawing my triangle here, and this is a 60-degree angle. The answer isn't 60 degrees. If this is the key spot, how do you get there? All the way around like this. It'd be 300 degrees. You get that? Good. Don't talk over me. Get that? Okay, now you have a question? I just drew a new triangle. I just made up a new one. Oh, okay. So you're asking, wouldn't this be one of two answers? No, because those problems always say, look at the directions here, between 0 and 360. Notice there's no negatives in it. Okay, we don't want negative answers. All right. So if they're not negative answers, there's only one way to get there. Yes. 210 would be the answer. Done. Nope, just that. And yes, it needs a degree symbol because this problem is in degrees. Yes. Okay. It's where this line is. So if I make another one, it's like right here, that's the key line. And so yes, this angle here might be 45, but I wouldn't say 45 then. I would say, there's my angle, which is actually 135. Yes? Share your hand up first. Go ahead. Yep. Okay, the question on this one was, how do you know where to start this question? Is that what you're asking? Okay. Well, there's only one place that I could draw this. Do you get the? I'm gonna actually just erase. I'm gonna do undo on this all the way back to the beginning of time. And when I very first started, the first thing I said was, let's not use those two quadrants. Do you get why I started that way? Because I knew cosine had to be negative, so it couldn't be there or there. That's how I knew to start. The next thing, I could have just gone and drawn a triangle in one of these two, but I had one more piece of information that told me a lot. Tangent was positive. That meant it had to be here. That meant I couldn't use that spot. Okay? And then how do you start after that? Draw a triangle. Again, if you're not sure, just draw a triangle. It almost always ends up being draw a triangle. So I'm going to draw a triangle, and I always have to have that triangle have the central angle. That's the angle right there. Is the important one. Okay, so make a nice central angle there. Now, how long are its sides? I don't know. I kind of make it a bland triangle. I don't make it super long and skinny or anything. And then I just label the sides based on cosine's adjacent over hypotenuse. So the adjacent would be negative root 3, and the hypotenuse would be 2. Okay? And after that, you got to start recognizing, oh, that's the 1, 2, root 3 triangle. This must be a 1. And then you got to be smart enough to know it's negative 1. And then you have to go, okay, so that must be 30. But that can't really be 30. It's got to be all of that. Okay, the negative is not the angle. That negative is a side length. Remember that if the negative was over here, then you'd be going the other direction, okay? This negative is on the side lengths, and that means the side of the triangle needs to be negative. All right, next, I want to give you another one that's a lot like that. Try this one. Tangent of some angle is equal to 1. And cosine of the angle has got to be greater than 0. Try this one, yes. Okay, whenever the question was how do you decide where to put the negative? If you're drawing a triangle, if I draw a triangle here and here, I know that this direction, downward direction, that's negative. So that side has to be negative. Okay, this one would be negative in this case. And would this be positive or negative? Well, it's going to the right. Think of it as if you're on a plane back to when you first learned this in like 5th grade, these numbers are positive here. But if I go down this way, those numbers are negative. Negative 1, negative 2, negative 3. You know what I'm talking about? the hypotenuse is always positive. Always, always. In every single place you ever draw it, the hypotenuse will be positive. Okay? So if I were to draw one here, let's just see if you would know. Side 1, 2, and 3. And they're not lengths, they're just like side. Let me in fact change it to A, B, and C. Which side do you think would be negative? A, B, or C? A would be the only one that would be negative. Good. Let's try another one. Top right, I can do one up there. Let's say this is A, this is B, and this is C. What would be positive in that case? Good. Okay. Then what if I draw it down here? Let's say this is A and B and C. Now what's positive and what's negative? You're right. A would be negative and B would be negative, but not C. That can never be negative. Okay? You get that? All right. This is just defined. It's a radius. You can't ever let that be negative. All right. So now, back to the problem I gave you. I'd like you to see about this one. Where should I be? I hope you know that if tangent's positive, all students take calc, it must be here or here where tangent's positive. So it can't be here and it can't be here. Right? And it also says cosine is positive. That means that if cosine's positive, it must be here. It can't be here. Okay, so I have to be drawing it right here. Now, if I'm going to draw this triangle, tangent is 1. I'm going to put over 1. Don't you agree that you can always put something over 1? So I give you two sides. The sides are 1 and 1, opposite and adjacent sides. Opposites 1, adjacents 1, 1, 1, root 2. I'm getting close. And then I can tell it's a 45-degree angle. So the answer is 45. Good question. I didn't label it here, but since we did the last one in degrees, I just did it in degrees. But if they give it to you, I'd say it's more likely than not going to be in radians. If you had 45 for an answer, do you know what that would be in radians? Pi over 4. In case you have not got these memorized, I really encourage you to memorize them. They'll make it so much easier. Otherwise, you'll have to do this, multiply by, and pi over 180. And then you got a pain in the butt. You got to reduce 45 over 180. That's kind of a pain. 45 goes in here once, and then there 4 times final answer pi over 4. But a lot of people don't know that 45 goes into 184 times. So memorizing that would be smart. Okay, any other questions on that one? If it does specifically say radians, you have to use radians. It will say it in the directions. And if you're ever not sure, you can always ask, Mr. Server, on this problem, do you want it in degrees or radians? I'll tell you. Don't just assume. All right. Next, we need to get to one of these kind that are kind of annoying because you can't draw a triangle for them. Okay? All right. Sine of theta is equal to 1. And I want to know between 0 and 2 pi, which means I want the answer in radians. What are the answers? Well, did I give you sides or did I give you an angle? First thing I would ask you, I did not give you an angle. I gave you sides. The angle's right here, and it's unknown. It's a theta. So I gave you sides, and couldn't you always put this over 1? Sure you can. But I hope you realize that if you're trying to draw a triangle for this, that the opposite and the hypotenuse have to be the same. That's a weird triangle. Anytime you get into a triangle that is really not possible and weird, then you must be at one of these spots called the quadrantals. It's one of those places where if you're here, you can't draw a triangle because I'm supposed to make the thing drop down to the x-axis. You can make an imaginary triangle. We talked about that, but I don't want you to really focus on that way. There's another way that we used more. But you have to know the 4 spots for the quadrantals, and I suggest you use 0s and 1s for these places. What would this place right there be called? What comma what? 1 comma 0, I think, isn't it? Over 0, over 1, up 0, right? And how about this spot right there? 0, comma 1. How about this spot right here? Negative 1, comma 0. And how about this spot right here? 0, comma negative 1. If you don't have those memorized, you got to learn them and memorize them, because there are going to be quadrantals on the test. I would guarantee you that that's a big topic, because it's like, it's either triangles or what if you can't draw a triangle? Like this one. Then you need to have these other little formulas memorized. That in that case, sine of theta is y over, anybody remember? R. And cosine of theta is what? X over R. And the last thing is tangent of theta is what? Y over X. Again, you've been behind, you have not been memorizing stuff like you need to be. That's got to come naturally by now. Otherwise, you're starting to get behind. Got to memorize those. Okay, now, how do I use this? Well, if I want sine to be 1 over 1, then really what is this? Sine is like this, right? So isn't it really like y over r? So I really gave you y and r. In what spot is y equal to 1 and r equal to 1? Is this spot where y equals 1 and r equals 1? No, y doesn't equal 1, y equals 0. Is this a spot where y equals 1 and r equals 1? Yes, it is. That's the spot. So what did I need to give in the first place? I needed to give an angle, because they already gave me the sides. What angle is that at that spot? Pi over 2, otherwise known as 90 degrees. But again, because they wanted the answer in radians, you have to say that was a pi over 2. Final answer, pi over 2. Is there another one for this one? Nope. Because I need to find a spot where the y is 1 and the r is 1. Is this spot where y is 1? Well, kind of, but it's negative. Okay, so that wouldn't work. It had to come out to negative 1. And is this a spot where y is 1? Completely not. These don't work. Only that spot works. Where's that spot? That spot's at pi over 2. Answer's pi over 2. How do you tell if they want it in radians? You look at this thing right here. And if that says 360 right here, then they want it in degrees. If that says 2 pi, all right, let's do another quadrantal one. Yes. There can always be more than one answer when this thing is present. It's usually a hint that there's more than one answer, but in this case, there's only one. Because this was supposed to equal positive 1, and the only other one that was close was where y was negative 1, but that's not the same. All right, so again, two things you'll need to know on this one. This spot right here, 1, comma 0. This spot right here, 0, comma negative 1, etc. Okay, you're going to have to make those. You'll have to have those other ones, y over r, and x over r, and y over x. What's this one again? What? Tangent. What's this one? Sine. Is that one? Cosine. Okay. Now, given all that, tell me, where is tangent of theta undefined? Well, right away, you know it isn't a normal triangle, right? So you know it must be one of these quadrantals. Find which of those 4 spots work. Maybe there's 2. I'll tell you that the answer on this one needs to be between more likely going to be in radians than in degrees. So. Okay, work on drawing the circle and triangle first. Mr. A in the back row, which of the quadrantals do you think it is? Did you figure out which one already? Okay, how about this? Give me some choices. What are the ones? What's this? 1, comma 0. What's this? What's this? What's this? Perfect. Okay, now, remember what tangent's supposed to be? So really, this undefined thing is supposed to be y over x. Think now. Is y 0 or is x 0? X must be 0. That tells you a lot. Which of these things have an x that's 0? Does this one have an x being 0? No, that's got x being 1. How about this one have an x of 0? No. That one's got an x of 0. And that one's got an x of 0. Would they both work, or would only one of them? Yeah, both, because if you put in x to 0, you don't even care what the y is, right? If I put in x to 0, it could be 1 or negative 1 on top, and either way, it's undefined. So the answer is both those spots. And if I had to say both those spots in radians, what's this spot? 2. And what's that spot? 3 pi over 2. That's just telling you whether you want the answers to be, first of all, it tells you that there's more than one answer, usually. The second thing is, it's telling you that the answers can't be negative, because see, it's between 0 and 2 pi. It doesn't go the negative direction. And the third thing it tells you is it wants the answer in radians, because see, there's a 2 pi here. So it tells you 3 things. That they need to be positive. It's kind of a hint that there's usually more than one answer. And last, that it has to be in radians. So here's my 2 answers. They're in radians. They're the 2 spots that we're looking for. All right. Need another one on that, or do you feel like we've hit that one long enough? Another one? How about this? Give me a thumb. I want another one, or I don't need another one. Give me another one, or no more. I'm getting mostly no more. Okay, good. Then, let me teach you graphing. Grab your worksheet that you had due today, but you didn't have the graphing part done. Okay? That's that. Would you read me that first one, number 3, that had a graph on it? All right. Well, that assumes I know what sine x is. And so we're going to make this unit relatively easy on you when it comes to the graphing part, because you could always start by graphing the parent. Just do it in pencil. Okay, so you can have the parent on there, and a lot of times you won't have to do anything except renumber the graph, and I'll show you what I mean by that in a second. So do you get that there's 4 major spots for any graph? There's 4 major spots. They're the same 4 major spots as we had back here. That, and that. This was pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Well, those 4 spots are on my graph again. Except now they're 2 pi's here, pi is here, and this is pi over 2, and this is 3 pi over 2. You got to get that those are the 4 major spots. Now, really what I'm helping you with right now, this is the stuff that's going to be tested about a week from now. Not the test on Monday. The test on Monday is more like the other stuff we covered earlier. All right, so now I'm going to get this pi over 2 and pi and 3 pi over 2 and 2 pi thing into the graph for sine. Sine starts here, goes up to 1, comes back down again, goes down to -1, comes back up again. There's the graph for sine. Good enough. Is that 1 period of pi or 2 periods of pi? 1 period. That's 1 full cycle. It's got to go up and all the way down. It's kind of like a high tide and a low tide. Okay? You need a high tide and a low tide to make 1 complete cycle. And then it starts over again, right? All right. So now, let's say I want to do this too. First thing, you'd have to say what changes are there. Like on the test on Monday, they'd ask you, what is the change from the parent? And you'd have to be able to say, oh, it's 2 times what? Oh, okay. Or a vertical stretch factor 2. So that, what would that actually do? That would make it go up twice as high and down twice as low. See how the green one would be my final answer. Just made it go twice as high. Done. That's the answer. So if you were doing that on your worksheet, may as well do it right on the worksheet, because that's what your assignment for today is to finish that worksheet and then start this next one, which we'll just start today. Question? Yep. What if it had been, I'll back off for a moment. Let's say this had been a half. Well, then I'm just going to make it half as tall. So I'll do that one in blue here. So half as tall. Half as tall. You know what I mean? We're not going to be that nasty to you. Okay? Let me show you. Let me show you. What we would do then is, see, do you agree that this is going up to 1 right now? And down to -1? What if I said, now I'm saying it's going up to 2? See what I mean? Now I'm saying it's going down to -2. I don't even have to change my actual picture. I can just change the numbers. That is allowed. All right, so on this graph, the original problem was 2 sine x, right? I could have just taken my parent graph and said, instead of this being 1 and 1 like it normally would be, it's 2 and -2. But if you don't actually change those numbers, not giving you the credit, of course. Because then all you did is graph the parent one. But if you want to make this stretch be twice as tall, you do that. What if you want to make it 7/4 as tall? 7/4. -7/4. That's it. Yep. You can just do that. All right. So let's go to another one. Look at the next one. Is that what you're talking about? Okay. So would you read me number 4, please? All right. This one does have 2 tricky things going on. Let me help you understand it. First of all, I got -7/4 to deal with. And then I got sine of, I really encourage you to write this as 1/3 x. X over 3 is the same as 1/3 x, and it'll be way easier. Okay, so then, you got your little picture. You say, I need to graph sine. Every single time, just graph the parent. So here's the parent one. There. I've graphed the parent. Next. This would normally be 2 pi and pi and pi over 2 and 3 pi over 2. So that's how I'd always start. This would normally be 1 and -1. We just talked about that. What do we need to do? Change it to 7/4 to -7/4. Now this is the one thing that we're never going to let you just try to do on the graph numbering system. This, what do you think that does? Flips it. So now it's this new one, this black one. And we get rid of the red one. That's why you should really do these in pencil. I can't. Get the idea anyway here. There. Now, what haven't I dealt with yet? The 1/3. I did the flip. I fixed the 7/4. That's the way I would do this. I think of it like a checklist. Okay, I got this done. I got this done. I haven't done this yet. Okay, first, before I do that, Nope, we don't want you to reverse the positive and negative. Then it's messing up the graph too much. So, yeah, you are going to have to actually reverse this. But they're really easy to reverse. They really are. I get what you're saying. You can try to make this negative and this positive, but we don't want to do that. That's like, we're trying to give you a break by letting you renumber it, but that's just taking it too far. Whenever there's a negative, you'll have to flip it. All right, so the last thing I got to do is this 1/3 part. Listen close now. This is the hard part for the lesson. It's not super hard, but it's the hard part. Do you remember that the period is the time it takes for this thing to finish, do a full cycle? Remember that? Its normal period's 2 pi, right? And we have a little formula for the period. Its period is 2 pi over b. Right? What's the b in this case? 1/3. So you got to go 2 pi over 1/3. This is why we tried to weed out the kids early on who couldn't possibly handle fractions, because now you got to handle this. What's 2 pi over 1/3? It's 2 pi times 3. You flip the bottom one. You leave the top one alone and flip the bottom one. 2 pi times 3. 2 pi times 3. 6 pi. Now, what does that really mean? It means that this thing is supposed to finish at 6 pi. Right now it's finishing at 2 pi. So technically we should make you stretch this thing out and make it go like this and finish at 6 pi way the heck over there. But we're not going to make you do that. We're going to have you renumber it. We want you to have it finish at 6 pi now. What's currently at the place where it finishes? So you can be smart about this. You can do this the hard way or the easy way. When the cop asks you that, always choose the easy way. Because if you say you want the hard way, then he's going to take you down and use the taser and the mace and all that. Okay. So you want the easy way. All right. How do I get this to be 6 pi? Well, I can just say it's 6 pi. Then I got to realize, what did I really do to the 2 pi? I times it by 3, yes. So then that really just means I take each of these and times it by 3. Times it by 3. I didn't divide it by anything. I times it by 3. And your final answer, you will have to simplify that. And so what is this one? It's 3 pi over 2. This one's 3 pi. This one's 9 pi over 2, and that's totally okay. Notice it only times the top by 3. Some of you guys have that weird habit of timing both the top and the bottom by the number. You don't do that. And then the last one is 2 pi times 3 made the 6 pi. So here's my new numbers. That, and that's the hard part. Yes, you do. All right. So the good part is, I'm going to tell you, if we made you actually stretch this thing out and try to have it finish, it would be way, way harder to make these graphs. It's way easier to change the numbers. All right, so now let's do another one. Look at your worksheet. Next one. Number 5. Would you read me number 5, Mr. M? Cosine of 7x. All right. So, cosine of 7x. Well, that seems pretty easy. I just got to know what cosine looks like. 4 spots. 2 pi here. Pi here. You're going to get really good at this. What's the spot right here? Pi over 2. Good. And this spot right here? 3 pi over 2. All right. Cosine does not start at 0. Cosine starts at 1. And it goes down. And it makes like a valley. Okay? And then it comes up and ends at the same exact spot. So it ends here. And exactly in the middle of the whole thing, it's at its lowest spot. And I made the middle one the lowest spot. Right there. And if yours is this ugly, it'll be okay on the test. It doesn't have to be beautiful. Okay, but it makes a big valley shape. And of course, if I repeat this, it'll make the wave you'd all be looking for. It waves up and down between -1 and 1, over and over and over and over and over. Okay. Now, that's normal cosine. Is this normal cosine? No, it's got a 7. What's that? A, B, C, D, or E? That's B. And what's that little thing that tells me something important? It's the formula period is 2 pi over B. What's B? 7. So B is 7. My new period isn't 2 pi anymore. It's 2 pi over 7. So I have to rename this as 2 pi over 7. Now just think, this is the easy way. Think, what did you do to 2 pi? Because you can just do that to everything. We divided it by 7. It might actually be easier to think of it as multiplying it by 1/7. Because then I can take everything and just multiply it by 1/7. You know what I'm saying? Multiply this by 1/7. Multiply this by 1/7. So now, it's not 2 pi anymore, it's 2 pi over 7. And now it's 3 pi over 14. And now it's pi over 7. And I'm multiplying these and I get pi over 14 again. Okay, so when you're changing a number on the inside like this, remember that the period is 2 pi over b. That's going to be the hardest part, is the renumbering of these things. Like we just, there's my 4 new numbers. You don't really have to change the graphs that much. You start with the parent graphs, and the only time you really have to change them is if you have to flip it. Otherwise, you just leave the graph alone. It's just changing the numbering. Let's do one more together. But question first. If you don't simplify these fractions, yes, they would be marked wrong. You do have to reduce them. 3/14 can't be reduced, and neither can 2/7. So those are pretty easy. All right, so let's move on to, let's skip number 6. We got only one more in that section. Let's do number 7. Would you read me number 7, please? All right. That's got 2 things happening. That 0.5 is the amplitude. Remember, that's the amplitude. On Friday, I'm going to focus you in on just what you have to know for the next test. But today, I need to still mostly focus on the graphing part. But a test question for tomorrow would be all just like, what's the amplitude? And you'd say 0.5. No, sorry. When we review tomorrow, the test is actually Monday. Okay, but when we review tomorrow, I would be just asking things like, what's the amplitude? 0.5. And the next thing I might ask is, what's the period? And the period is 2 pi divided by that. 2 pi over 3. So, but anyway, this graphing one, I'd just start by having your 4 key spots labeled. 2 pi, pi, pi over 2, 3 pi over 2. You always start that way. Always, always. And then I just got a graph sign. Sign starts at 0 and goes up. Bing. Don't spend too much time on those. Just a wave. Okay. Now the hard part is the renumbering. Think of this as a checklist. Have we done this yet? No, we haven't. We've already done the sign part. Check. But we haven't done the 0.5 part. We haven't done the 3 part. Let's do the 0.5 part. And what does that do? It should make it half as tall. Now you could actually draw it half as tall, like this. Do you have to do it that way? Nope, you can renumber. So if I'm going to renumber, I would say instead of this being 1 and -1, I'm going to change it to a half, or 0.5. It's the same thing, I'd be fine with 0.5. And then, check mark, done with that. Now how about the 3? Have I done the 3 yet? No. How do I do the 3 again? Yes, it's the period. It's 2 pi is normal. Divide by 3 in this case. So my period should be 2 pi over 3. So I make this 2 pi over 3, and notice I divided by 3. Again, my advice is multiply it by 1/3. If you want to try dividing these by 3, you have fractions and fractions and a big mess. So instead of doing that, times everything by 1/3. And your final answer for this one, pi over 6. Hey, I know that one. That's 30 degrees. And the final answer for this one's pi over 3. Hey, that'd be 60 degrees. And then this one would be 3 pi over 6. You really shouldn't leave it that way. I don't know if that was the only mistake you made, if I would have marked it wrong, but 3 pi over 6 would reduce to pi over 2. And I think. Yeah. And then the last one's 2 pi over 3. There's my 4 numbers. Do you think you get this part now? Good. That's the basic graphic. The only other thing there is to worry about is if they shift the whole thing. And we're not going to worry about that today because we have enough to worry about. All right, so if they shift the whole thing, you would just do all the things we just did. And usually they wouldn't have like 3 changes and a shift. It'd usually be just like maybe a stretch and a shift. And you have to shift something, that's when they look like this. Sine of x plus pi over 2. That's where you'd find normal sine of x. You still start by graphing the parent. I'll just do it super fast. There it is. And then I got to shift it that far. How far is that far? That's pi over 2 is this far. So I shift it that far. And if it's positive, do I shift it to the left or to the right? Left. So I'm going to just use the wonders of technology to draw right on top of that. Then I'm going to grab this and move it so that it's effectively shifted to the left. Okay. Anyway, where I could grab this blue thing, maybe that'll make more sense to you. I'll move it left. Okay, so what do you have to do? Finish this worksheet. Okay. This one doesn't have any shifts on it. And then the assignment that I was going to give out today, just normally, if we'd have just kept the normal course of things, is this one. And I'm going to have you do any of them that don't have shifts in them. And so anyway, actually, wait a minute. There's not many shifts in this at all. That's good. Okay, I'm just going to have I'm going to have you do a few off of this worksheet for today. So finish that worksheet. That'll be easy. And have a few off of here to do for your homework for tonight. So this is the 4.4 worksheet number 2 I'm handing out right now. All right, to my 6th hour. I hope that you were good for Mr. Tuthill today, and I really appreciate you guys doing your best, and I hope to see good work when I come back.